All right, welcome everybody to Across the Sky podcast with the Lee Enterprise Meteorology Group. I am Kirsten Lang. I'm in Tulsa, Oklahoma with the Tulsa World. And joining me are my other three colleagues. We have Sean Sublett, who is in Richmond, Virginia, Joe Martucci in Atlantic City, and Matt Holliner in the Northwest. Hey guys, how are you doing?
All is good here in Richmond, Virginia. The sun is back out. Humidity is edging off a little bit. Anytime the humidity edges back off in June, we're happy.
Good to hear. Joe, how is it? How is Jersey, man?
Listen, Jersey's always good. Always a good time here, hanging out at the beach. Although I got a little gripe I have to gripe about for 30 seconds. Trying to buy a car right now. You cannot find a car under sticker price anywhere. I have called places near and far. You haggle, you bargain. It doesn't work. So, personally, things are a little shaky on the car front, but otherwise in the weather world, we are looking good.
Yeah, my husband and I were driving around yesterday and passed a car lot, and we just couldn't even believe it. I mean, there were maybe 30 cars on the lot. It was crazy. So
yeah, it's nuts.
Sorry, Joe.
It's nuts. What a
Matt,
world.
how are things?
Well, let's be honest. Is there anything that's cheap anymore? I mean, I'm talking about any kind of product. I mean, everything's gotten more expensive. I mean, we could do a whole podcast episode on that. But
Arizona iced tea still 99 cents, Matt.
Oh, okay. There you go. One thing.
How are gas prices?
Midwest.
I'm curious. Matt, how are gas prices in Chicago?
Oh, you don't really want to know. Last I saw, it was going for about $5.32 a gallon. Yeah, it's not good. So, but people are still driving. They're hanging in there. I mean, the problem is the weather is so nice right now. I mean, everybody wants to be out and about and going and doing things. I mean, we got some temperatures. We're looking at some potential really warm temperatures next week. But right now, temperatures in the 70s, feeling great. You just want to be out and about.
All right, good deal. And Tulsa's pretty nice. We've had kind of off and on showers and storms all week. It's been kind of an active week. But as we head towards the weekend here, we have the Tulsa Tough that's going on, which is a tournament, a bike. I don't know if tournament's the right word. Competition tournament. It's going on this weekend, and it's a bike event. So that happens Friday, Saturday, Sunday, and thankfully all the rain will be out of here. And our guest today is actually just down the road from me. He is in Norman, Oklahoma. It is Harold Brooks. He is a senior scientist in forecasting and research development with the National Severe Storms Laboratory, again, in Norman, Oklahoma. And we have him on today, and we're so excited to chat with him. Harold, how are you?
I'm doing pretty well, as far as I can tell. I'm glad to be here today, and hopefully things are going on. We are a vehicle short in my family. So we're going to be making a decision. My adult child who lives across the street, we have to figure out whether the vehicle is going to go to them or to me, and how it'll be used and cheap.
Or
relatively cheap.
Listen, it's a wild world out there in the car buying world.
And weather-wise, yesterday morning it dumped like mad here at the National Weather Center, to the extent that for about 15 minutes I couldn't see Lloyd Noble Center, which is where the University of Oklahoma plays its basketball games, which is about a quarter of a mile away. The rain was hard enough that I could not see it. That was interesting, let's say.
I was looking at the radar here in Tulsa, and I just peeked a little bit to the west, and I saw you guys, and I was like, man, that just stinks. It was.
Yeah, I got in as part of the vehicle short thing. I take the I live half a mile west of the OU campus, and I walk over and I take their bus down to the weather that drops you off at the weather center. And one more bus later would have been a very interesting last little walk into the building.
One you probably wouldn't want to take at 7 or 8 a.m. in the morning.
Yeah, it would have been, I probably would have just sat out into the shelter for a long time.
We wanted to talk with you today about a topic that I think is pretty popular right now. And as you said, it's kind of cyclical. It depends on the season and what's going on. But a lot of people have inquired about whether or not Tornado Alley is shifting. And it's something that I recently wrote a column on. I chatted with you a little bit about it, but we wanted to bring you on the podcast, and all four of us kind of wanted to ask you some questions about it as well. So, just to kind of kick it off, I think the main question a lot of people ask too is really, is there a true definition that you would say of Tornado Alley, and how would you say that's changed over the past several decades?
There's no real definition for Tornado Alley. It's a colloquial usage, which probably has some usages. As far as we can tell, it was first said back in the 1950s. Appears to be about the origin of it, and it was at that point it was intended to describe an area of the plains in the United States. But that one of the key things when we look at that, there's no time period in which we have tornado records back at least for a century in which you would actually have ever drawn the plains as something like Tornado Alley simply based on the number of tornadoes that occur. The best early records we have, which back to 1921 to 1935, the actual maximum of tornadoes at that time was over eastern Arkansas over that brief period of time. And so it's clearly something other than just occurrence, frequency of occurrence that leads to people calling that Tornado Alley. Did a little bit of work years ago that in some sense, I kind of regret drawing a figure I put into a paper because it led to a lot of that coming up that indicated that probably one of the things that people look at is the fact that there's a really strong annual cycle and diurnal cycle in the plains, in addition to there being lots of tornadoes. And with the relative lack of trees, tornadoes are more visible. So almost all of your old classic tornado photos are out of the plains, and that's occurrence, but it's also visibility and the repeatability of the season.
Harold, it's Sean, and you were getting ready to go right into my next question in terms of how this phrasing came about and having to do with the visibility. And my assumption here, and please correct me if I'm wrong, because you are much deeper in the data than I am, is the proportion of 3s, 4s, and 5s on the EF scale any higher in the plains, in a Kansas and a Nebraska, Oklahoma, Texas, versus someplace like in the interior Southeast, like Arkansas, Tennessee, Alabama, Mississippi? Is there any signal there in terms of the EF scale of the tornadoes in the plains versus someplace like the Southeast?
As best we can tell, the answer is no. There are a couple of places there's some special places in which the distribution of tornadoes by intensity is different. The Front Range of Colorado, where we get a lot of landspouts. Peninsular Florida, where we get waterspouts coming on shore. We also get some, landspouts, depending on how you want to define things based on the convergence of various boundaries that take place. And we actually see a similar thing when we look at say, peninsular Italy or southern England. We see a distribution there where the tornadoes that violent tornadoes are less likely because those processes seem to be much more difficult to get a strong tornado out of them. But even when we look into continental Europe, the distribution by intensity is very similar to what we see in most of the United States. The reason they don't get as many violent tornadoes in Europe is that they don't get as many tornadoes to start with. There may be a slightly lower probability of the extremely violent events, but it's not by very much. So as far as we can tell, except for those special places where we're right in the Front Range of the mountains, and the Palmer Divide's having an effect on non-supercell tornadogenesis, or Peninsula Florida, everywhere else the distribution by intensity is the same.
Yeah, I guess I'll go. When it comes to keeping track of the number of tornadoes, I'm curious how much of it has to do with the fact, that there are just more storm chasers out there. There's more video cameras out there now as far as documenting the number of tornadoes. So I'm wondering how much of it is playing into effect as far as the number of tornadoes that are occurring and where they're occurring. Is it more a factor that there are just more people around that we are documenting these more? Or does it seem to be that there is a climate change element to this, that part of the reason where we're seeing this shift in the tornadoes occurring and the number of tornadoes occurring is climate change, or is it a combination of both? And how do we tell which one has a bigger impact right now?
The answer to your question is yes. It's all of these things come in. We know that there are certain quirks in the database that have been in historically in a long time. I think we can see the impact of the first research campaigns that took place in the 1950s in Oklahoma and Kansas. I think we can actually see that effect, that people were actually looking then. We know that interest and the ability to collect reports and the emphasis that Weather Service offices put on them have a big effect. Tornadoes are, we've seen an increase in the number of tornadoes reported basically from the 50s up until about 15 years ago. We really aren't, it's been pretty flat since then, but the increase has been entirely in the F0s. F1 and greater tornadoes, that's been a relatively constant thing. There's about 500 a year in the United States of F1 and stronger tornadoes, and that's been true since the 50s. Now, the really interesting thing is that there are lots of non-meteorological factors in the database. And pulling them out is, some things are easy, some things are, we're just trying to make good educated guesses. One of the big hiccups in the database is actually in the late 1970s. The Fujita scale was proposed in the early 1970s. Ted did some damage surveys on his own, particularly the super outbreak in 1974, where all those tornadoes were rated by Ted and his team of people going out and looking at things. The Weather Service started experimenting with a few offices with doing ratings in 1975, and that spread around the country to where by sometime in 1977 or 1978, they were rating all of the tornadoes in close to real time. Well, somebody had the good idea of, we've got all these tornado reports sitting here from 1950 when the Weather Service officially started trying to collect them. Up until 1977, we ought to go back and rate those tornadoes rather than just have tornado in it. And so they took the text description of the damage and had the pictures and Fujita's description of the damage and his canonical pictures that went with damage at different levels. And they gave them to a bunch of undergraduate students as a summer project to rate those old tornadoes, because that was the cheap thing to get them done, was to hire undergraduates. And the thing is, the curious thing is that they told that the default rating that they started with was F2, and they had to have evidence to change from F2. And one of the real issues was, there might be a text description of a tornado that says a house destroyed. No description of what the house was. If it was a, 3-story mansion, or if it was a sharecropper shack, it would just say house destroyed. And they had to determine the damage. And it appears when we look at that they probably overrated the tornadoes by about half an F scale on average. When we look at the distribution, when there was no damage, they went with F0. And so it looks like the F1 and greater, if you just do that, yes, no, it was F1 or stronger, that stayed pretty good and stayed pretty consistent. But things above that are overrated in the old record. You really can't go back and look at F2 plus, F3 plus back before the late 1970s. And then we have the other things that happened, the emphasis on engineering of structures that I think has led to us decreasing the number of very violent tornadoes in the database in the last 10 to 20 years. The EF scale coming in had an impact on our rating of intensities and some of the other characteristics. So the database is a little bit of a mess in a lot of details, and it takes quite a bit of work to figure out what actually seems to be reasonably reliable.
Just to follow up with Matt about cell phones and increasing tornadoes. I chat about this with someone that you actually went to Columbia with. I don't know if you know him though, Dave Robinson.
Yes.
That's my good buddy, my birthday buddy, Dave Robinson. He's actually on a podcast that I host myself. I have him once a month.
Oh my gosh.
Yeah. Great guy. So we talk about this with the tornadoes. He says that, in New Jersey, right? Because we're focusing on New Jersey, that that cell phones don't really play a role into this increased amount of tornadoes. And he will point, at least in the New Jersey record, that the late 80s were also very active with tornadoes, just as they are now for us here, not only in New Jersey, but across the Northeast. So I just want to dive into that cell phone video camera thing a little bit more. Like, are there actual numbers to back up that cell phones are or aren't increasing this, or, video cameras, whatever?
It's really hard to tell if they're having much of an impact. I mean, because there were still, back in the day, like in the 80s, we still would have, back in the, when chasing was starting to get to be a little bit more popular than it had been before that, those people who chased in that era, we were all pretty good about thinking about, making sure we got that report to the office. I saw a tornado. I got a really bad picture of it, but I saw a tornado. So I think now we just have things that are a little bit more publicly and widely shared, but that perhaps I think the Weather Service probably would have heard about them from someone in the spotter world.
Okay.
Somehow, anyway.
So maybe it makes a difference before the 70s. You think maybe it makes a difference before the 70s, kind of like you were saying? Before that,
well, not the cell phones, but
sure. Oh yeah. Sure.
But yeah,
even video cameras or whatever.
But things happened along the way, and a lot of it, simply came down to, if you saw a tornado, did you actually think to report it? And there's someone who was actually trying to collect reports? Weather Service offices now are a whole lot more outgoing about trying to get reports of events than they would have been, 40 years ago, and that's, I think, a big part of what's happened is that their connections with the communities are better than they were, and so those reports come. But really, the total number of tornadoes in the country really hasn't changed on average since 2006-ish. We've been kind of constant in the 1,200 range.
All right, we're going to take a quick break, and we'll be back briefly just after this with Harold Brooks in our Across the Sky podcast. Stay with us. And welcome back to the Across the Sky podcast. I'm Kirsten Lang with the Tulsa World here in Tulsa, Oklahoma. We have Joe Martucci in Atlantic City with Press of Atlantic City, Matt Holliner in the Northwest, and Sean Sublett in Richmond, Virginia. And we have Harold Brooks with us today. We're talking all things Tornado Alley. Harold, it's a very popular topic, I think, especially here in Oklahoma, but it's a popular topic kind of all over. And I know Sean had a couple things too he wanted to ask you about as far as Doppler radar goes. Yeah,
because we were talking a little bit earlier about detection and that fabulous story about the undergraduates back in the 70s and everything starting off as an F2 until you could prove otherwise. But that goes back to detection. And we know that the 88Ds, as we like to call them, the Weather Service Doppler radars coming online in the very early 90s and enabling better detection mechanisms, and then going to these dual polarization upgrades more recently. Have you seen any kind of jumps or change in signal and detection and or anything with false alarm ratios, or is it all just kind of a big gooey mess?
Well, the 88Ds, clearly Doppler radar is the single biggest thing for helping improve our ability to warn on storms. Prior to the Doppler radars, with just the reflectivity from the 74, from the 57s and the 74s, you saw reflectivity patterns, and tornadoes are wind. And so you couldn't see any circulation with you had to try to infer circulation. And I think one of the big things we learned when the 88Ds went out were that there were a lot of things that spun on the storm scale that had non-classic reflectivity patterns. And so I think we started to understand that there were that the menagerie of reflectivity patterns that could produce a tornado was a lot larger than we thought it was. But we also were able to see some things that allowed us to go, okay, that's not going to make a tornado. That might have actually looked like it was potential for tornado. So I think it improved a lot of things. For some things it's hard to tell what the impact on the tornado data, because the late 1980s there's a ton of evidence that the late 1980s were truly a tornado drought period. And so when the 88Ds come in right after we've had what was historically probably the lowest 4 or 5 year period for tornadoes in US history, or at least in the last several decades, now we put in the radar, well, what's the impact? Because you're coming out of a low. So the fact that things went up in the early 1990s, part of that is the fact that the atmosphere really was more active when the 88Ds come in. It would be nice to have the 88Ds a couple of years earlier or come in a couple of years later if I'm thinking about what the database actually looks like. And then the 88Ds also then allowed us with the Vortex Field Project in 1994 and 95, we started to learn some things from Vortex that allowed us to ask better questions of the 88Ds when we were interrogating them in terms of trying to make a warning decision, especially in learning some things that won't tornado. So I think that was a really big improvement too. When we go forward to having the dual polarization radar, we now know that there's a high likelihood that when you see, we can see debris signatures because the polarized radar essentially looks, it looks both horizontally and vertically at things, and pieces of debris look very different than heavy rain or hail because they're not, round or ellipses. They're chunks of stuff and they reflect differently. So we're actually able to see signatures that are well associated with debris is being lofted by something. And that's, been in the last decade. We've really been able to put that into operations. The problem with using debris signatures as a warning tool is that means it's already happened. And you might have confirmation or a stronger sense that something is occurring. So maybe for your next warning, it's helping. But if you wait just for the debris signature, you're already too late. And so they've had lots of effects on what goes on. We've had the whole question of how of the warning decision problem is challenging. We in some sense we can think of it as we're trying to discriminate between a storm that'll produce a tornado and one that won't, knowing that there's going to be error, and we can set a threshold for where we're going to, when we have to make a yes/no decision. We can change our threshold. There's a lot of evidence that the threshold changed to lower or to higher, requiring more evidence starting in 2012, at which point we lowered the false alarm ratio starting in 2012. We also then, when you do that, we miss some more tornadoes, hopefully mostly weak tornadoes, but we miss some more tornadoes in exchange for having fewer false alarms. I don't think we really fully understand that whole dynamic of the human decision-making process very well. For when warnings are being put out, everything that goes into them, and even probably more important is we don't know what should be a good target. What actually is the correct balance between missed events and false alarms. That's there's not anywhere near enough research on that topic to understand what is an appropriate target given our current level of ability to discriminate.
Harold, I wanted to ask you another question, kind of going back to the topic of tornado alley shifting potentially. And one thing that has been brought up by you before in discussions I've had with you before is about the 100th meridian. And its placement on the globe. Would you mind just at first, I guess, letting people know what that is in case they don't know what the 100th meridian is, and then tell us a little bit more about how you think that may have shifted and how that could have affected where tornadoes originate now.
Well, I recently returned from Page, Arizona, and stayed in a hotel across the street from the John Wesley Powell Museum. And John Wesley Powell was a explorer in the mid 1800s. He's most known in popular culture for being the first European to go through the Grand Canyon in a boat. But as part of his journey out to the Colorado River, he went across basically Kansas, and noted that there's a very strong gradient in moist conditions in the eastern part of the state and dry conditions in the west part of the state. And roughly the dividing line is roughly the 100th meridian of longitude. And so he used the phrase the 100th meridian to describe that break between moist and dry. And what it means meteorologically is a little bit open to question. It's probably related somehow in terms of in the long term to the average location of the dry line, which is a way to initiate storms that are potentially tornadic. And so it's related probably to the long-term climatological locations of where storms should be occurring. West of it, you just don't get very many storms at all. And the 100th meridian has been observed in a lot of ways. We now, instead of just using John Wesley Powell's, it's moist here, it's dry there. We have a lot of other proxies we can look at that. We actually have precip observations now, crop usage, paleoclimate data on what crops grew places. We can actually tell where that line has been pretty well in the plains. It's moved east by a couple hundred miles in the last 50 60 years or so, and climate models suggest when we as we warm the planet that will move eastward, and so that's consistent with that movement. Exactly tying it to tornado occurrence is hard, but it's tempting to say that that's related to this. There has been an increase in the last 50 years in the number of tornadoes in the Mid-South. Sort of think of Memphis, Paducah, and draw a circle around them, and something of a decrease in West Texas to western Kansas, about 10% over 40 years. So it's enough to notice. It's probably not enough to make a difference to an individual making decisions, because it changes the number of tornadoes that are close to you. If you take something that's close to you that happens once a decade, it means it now happens one more or one less time in your lifetime. So it's not that big of a deal for an individual decision maker, but it's consistent that things have moved. I mean, the bigger thing in terms of climate, probably the bigger thing about the 100th meridian moving east is the expansion of essentially the very arid Southwest. Because it starts to affect how, if you think of eastern Kansas as a agricultural area, Nebraska, maybe even into Missouri and Iowa, that starts to have a big deal, because it's hard to grow corn in dry areas. And so that shifts the balance between wheat and corn. It's probably its biggest thing. But right now we don't have all of the physical links to connect that change to that change in tornado location. But it's awfully tempting to think it's got to be connected. I mean, there's you got two things moving. It doesn't seem to me like it's exactly the right scale. But again, the 100th meridian would be an average position. We need to be able to figure out what's the distribution of dry line positions related over the years and how that's changed. I think there are some tools out there to do it, but they're not in my toolkit to do the research. And I don't think they're that easy from my perspective, they aren't that easy to implement. We may not have the data we need to really do the analysis back a very long time.
Hey, Harold, this might actually parlay into my second question. What you were just describing, is this some of the work you did with the Intergovernmental Panel on Climate Change?
I didn't. That was not. This is more recent than that. The big person.
Oh, okay.
The big person who's worked on that is actually Richard Seeger at Lamont Doherty in New York. That was my office mate back in graduate school. You mentioned Dave Robinson. Well, actually, I briefly shared an office with Richard, and that's been his big thing. Has been essentially looking at sort of Western megadrought, and that's what this movement of 100th meridian is mostly the biggest thing it does. But it's like, boy, that's something that looks an awful lot like where things are happening with tornadoes, and so it's a really tempting thing. We probably need to figure out how to do that, how to do the modeling work. So
got it. Go ahead, Matt. You had a question?
Yeah, I wanted to bring up, when it comes to severe weather forecasting, Storm Prediction Center, it seems to to me, that it just seems to be getting better and better, their outlooks that are going out. But I'm curious at what kind of verification has been going on there, especially because it is complicated. How do you verify a marginal risk day versus a high risk day and the number of reports that you get? So what is the verification process that goes in to the Storm Prediction Center, the thunderstorm outlooks that are becoming more and more familiar in the public? And then also what is being done to improve those severe weather outlooks and severe weather forecasts?
One of the big things that we did in the late 1990s that I was involved with at that time, I was the head of the group in the lab that was interacting directly research wise with the SPC, and one of the big things we did was we changed the definition for what areas of risk meant. And what we did was, and this was the beginning of the probabilistic forecast from the SPC. What we did was we defined the forecast officially are probabilities of coverage. Okay. And now they have those probabilities are associated with words. So marginal, slight, enhanced, slight, moderate, high risk. But officially, underneath that, they are expected area coverage. And what we do is we put the reports get put onto a grid that is roughly 50 miles on a side. It's a little bit less than that, and it turns out that it translates into something that's very close to within 25 miles of a location, but it's actually on a grid box. And basically you look at yes or no, is there a report in that grid box? And you can do that for any threshold. You could do it for violent tornadoes, strong tornadoes, anything you have. And one of the big things about gridding the reports, well, we talked about tornadoes increasing in the number of reports. The big thing that's increased has been the non-tornadic storms. We had a lot more hail reports and wind reports than we used to. Those have increased a whole lot more. And many of them are close to each other. You can get a good thunderstorm and get a whole bunch of hail reports from the same thunderstorm. So we put them on a grid, and then you basically do a job of what fraction of the grid box is inside of that area, so that if the numerical value associated with that level of risk was 15%, you would in the long run expect to have 15% of those boxes inside those areas would have something happen in them. And the forecasts are what we would call reliable. They turns out the SPC forecasts are at least the day 3 and under are very reliable. That means that the probability of coverage is when you put out 15%, on average 15% of the boxes do get events. The forecast, what we have known is that since over the last 20 to 30 years, the number of days, and we came along with that process, we came up with a method that basically said, okay, this would be a perfect forecast if we told you, if given the guidelines the forecasters have to draw the areas. We developed a technique called practically perfect, that this was, if we told you where the reports were going to be and you had to issue the outlook based on those rules you would put the outlooks on, this is what you would draw. And so that's as good as the forecast could be. And we were able to come up with a method that said, here's the forecasts that are at least better than what you might expect by random chance, given that we know something. And the fraction of those forecasts that are skillful each year, that are better than chance, has gone up dramatically. The average quality has gone up better. So those outlooks are a real spectacular success story. It's, what we do with them as we do more research, one of the things that's happening now, we're finding more tools that help us identify things better and be able to discriminate between non-tornadic and tornadic better than we used to be able to. That's I think a big deal, and be able to it's always, when you're doing convective forecasting, one of the challenges is always, are there going to be any storms at all? So will we get initiation? That's a big deal. There's also work going on the extended forecast, sort of the day 4 to day 8 forecast. I had a master's student who just finished that is trying to take some of those longer range models and actually just be able to predict, are we going to get isolated storms out of them? or are we going to get a linear mode of convection, which changes the threat? And so we're working on trying to do all those things to better hone it. I think still the biggest challenge that I think we can make progress on is the question of initiation. That's just a hard problem, because there are times when the atmosphere almost makes a thunderstorm. And the difference is between, is it blue sky today or a violent tornado? It's not, is it, a little thunderstorm and then a little bit bigger thunderstorm. There's a switch, and predicting switches is hard.
Hey, Harold, as far as the SPC, risk outlooks goes, right? We have marginal, then we have slight, then enhanced, moderate, and high. One thing I get from people who, I deal with, in the public here, are always confused by the words. I know you're putting your heads and you're going back. I know. And I don't know how much you're able to answer about this question, but it's kind of a two-pronged question. One, did you ever think that this product, which is more, let's say in the weeds, at least it's not super public facing, did become public facing through media outlets, myself included? And then two, how do we feel about the actual naming of it? Because I'll tell you what I do. And obviously I understand what it is, but usually I will go with a level 1 of 5 risk, 2 of 5, 3, 4, and et cetera.
Well, since there's all these young people on the podcast, with the possible exception of Sean.
Sorry, you're gonna take that?
Well, he's the oldest person other than me.
I have no other choice other just to take it.
Yeah. Back in the day, there used to be a header above the convective outlook that said for internal government use only.
Yes, I remember those.
And I remember being a graduate student and thinking, oh my gosh, I have such inside knowledge because I can see this. I better not tell anybody I can see it, because I'm not supposed to, who's supposed to see it. And that's an issue. And one of the things with the wording, there are challenges. One of the things that we have issues with on doing anything serious about changing the wording is that there are a lot of jurisdictions with emergency managers that their playbook and their requirements for what they do are based on what that word is. If you say moderate risk, the office just fully opened, we're doing this other service. If you say slight risk, well, it's, we got the one guy who's still hanging around in the office making sure something's happening. And so there are some people who depend legally upon the wording. Now, for the media, I don't think it's a great communication tool for the public, unless you're in certain markets that I live near or live in which they use it a lot, and our broadcaster staff, for good or ill, perhaps overeducated some of our public about what things mean. I will say this: I have a PhD student who, for his master's degree, we were looking at interpretations of the outlooks of the names, the colors, all those things. That was his master's. For his PhD, assuming everything works out, one of the things we're actually looking at is a project where the outlooks are currently expressed as absolute risk, 15% coverage. We're also going to be exploring what would you do differently if we told you this is 100 times normal, or 1,000 times normal, or 10 times normal. And now in some places, like New Jersey, slight risk is a really big deal. You don't get very many of those. And saying slight risk, that kind of seems to downplay it a little bit. So relative risk might be a really big deal to help you to be able to say, okay, this is the biggest day of the year, people, pay attention. If you come back out to say in Norman, I go back to the May 3rd, 1999 tornado outbreak, the commonly known to many people as the first Moore tornado, that is the climatological peak location and timing for a violent tornado in the United States is May the 2nd, 50 miles south of Oklahoma City. Okay. The Moore tornado was essentially the most likely violent tornado on record. Okay. So if we actually do a relative risk for that event, it's probably 10 times normal. You know, that's not 100 times or something. So we still need to keep track of that absolute risk, but we really want to explore the idea. One of the things that we are really trying to do with SPC forecasts and with even the local office forecasts is how can we create forecast information that people like the media and emergency managers can use to turn around and communicate and make it easier for, you know, people like you to get something useful out of it, and be able to basically, you know, turn around and show that product in a way that makes sense for your users. We're very concerned about what we call, you know, user relevant forecasts, that are something that helps somebody do their job better, whether it's you or help somebody respond better. You know, because if we can find better ways for broadcasters to communicate things to the public, we're probably going to be better off in how the public responds.
Yeah, thanks, Howard. Yeah, I appreciate that. I mean, you know, like you said, in Jersey, like a slight risk is, you know, that's a pretty significant risk. Enhanced risk, like if we get an enhanced day, that might be once or twice a year. I mean, that's the big thing for us. So, but it depends, right? I mean, Kirsten and Tulsa, like, you know, enhanced risk is, you know, what, every other week?
I was gonna say, well,
It's Tuesday. It's Tuesday.
It's Tuesday, time for enhanced risk.
I was gonna
We'd be
say
going crazy.
we've had a slight risk in our area, Harold. What, like every day this week? I think almost like 4 times.
Yeah. You know, they're just kind of, you know, it's kind of like the squirrels in the yard. They're there all the time. You know.
Yeah.
That's it. Cool.
Well, very good. Joe, did you have something else you wanted to?
No, I'm good. Floor is yours.
All right. Well, Harold, we really want to thank you. This has been a fun hour, and I think we learned a lot and got some very cool information from what you had to say. So thank you so much for joining us this time on our podcast, and we hope to maybe have you back sometime.
Absolutely, I'd love to. This was enjoyable.
All right, stay with us. We'll be right back after this break. Welcome back, guys. You know, Harold was great. What a great interview. What a lot of knowledge he has.
Yeah, I've never talked to Harold before, so it's my first time. He's willing to answer any and all questions, even maybe a little more controversial ones with the naming of the different SPC outlooks. But glad he hopped on and shared his knowledge. And I think we're gonna have to have him back on, maybe for, as Sean was saying, during fall tornado season, our second season, we can have him come on and talk about something else.
Yeah, I mean, Harold really is a great guy. I have known him for a while now. He's helped me out in a couple of other things in my career as weather and climate communications. He's always very willing to help, and he's very, very down to earth. That's one of the things I really enjoy about talking to him. He can put things in a way that most people can understand. I mean, obviously, the four of us, we're very deep into the science, and if we're not careful, we can go too deep into the science. But he's very willing to just call it like he sees it, and that's one of the things I really appreciate about Harold.
And I don't know, another thing that stood out to me is how far we've come, because the one story in our whole conversation that stood out to me the most was, you know, just how it was such an effort to rate these tornadoes back in the past and to gather this information where they weren't even giving these tornadoes ratings. There were just cards that had little brief descriptions of the tornadoes, and there weren't the videos, there weren't the pictures that existed, and how it was up to undergrads, I'd never heard this story before, to put ratings on these tornadoes that had happened in the past. And man, it doesn't happen anywhere like that. I do want to make it clear to the public that now the Weather Service always, I mean, very rarely is there a tornado that occurs that is not documented now with at least a picture, if not of the tornado, of the damage that has occurred. And so then the Weather Service goes out there with a survey team, takes a detailed look at it, at the damage that occurred. And we have this scale, advanced scale now, the enhanced Vegeta scale, where we can assign a rating, and it's not done weeks or years in the past. It's done in just a matter of days. And so we've just come so far in the severe weather enterprise and our knowledge of tornadoes and how we're rating them. And when you hear a story like that from how it was being done in the 70s, man, that just puts it in perspective of how far we've come and how much things have changed.
And I think the other point that Harold made with that, which I think was a good one, is that the local Weather Service field offices have much better relationships with the public than they did 25 or 30 years ago. They have much more regular communications with the communities that they serve versus back in the 70s and 80s. Not saying that those folks and during that time were doing bad work, because they obviously weren't. But there's a lot more awareness nowadays, I think, in the public of the work that the men and women of the National Weather Service do. And they've been doing phenomenal work, whether it's doing tornado surveys, helping out emergency managers. They do good work. And it's nice to see that more and more they're getting recognized for it.
Well, hey, I mean, look no further than all the followers they have on Twitter. I mean, I keep a track of what, our local National Weather Service is in Mount Holly and how many people tweet at them a day just with observations, hey, what's the weather going to be like on Sunday, all those kind of things. And now that that's brought into the public's, now that the National Weather Service has shifted over into that realm, they've been very good at collecting observations, especially snow. Sometimes, I mean, I don't know if you guys see it, but like the snow observations are so dense that we can out doing.
Well, Joe, now we got to go get Gary.
We got to get Gary. Hey, we can make that happen. Gary Zakowski, former meteorologist in charge. I'm sure he would love to come on. I just saw him last month, believe it or not.
Former meteorologist in charge at the National Weather Service office in suburban Philly there in Mount Holly. And he's retired, so he can talk a lot more freely nowadays.
Yes, he can. And he has already. He has, and he will continue to do so if we bring him in. So those are some good thoughts. Maybe I'll
cool.
We'll talk after this.
Yes.
All right, guys. Well, again, thanks for joining us this week for our Across the Sky podcast. We're glad you're listening, and we hope that you tune back in next Monday. Have a great week.